Hi, this is Steve, and I want to welcome you back to another episode of the Tech Leader Talk podcast. Are you looking for a successful approach to implementing engineering processes and building a culture of innovation? Then keep listening, because that's what my guest, Steve Massey, is going to be discussing with me today. Steve is the CEO and co founder of Prewitt Ridge, which creates software tools for engineering. He discusses what he and his team are doing to build new and creative approaches to engineering. And that's what we're talking about on the call today. Steve has previously worked for two space tech companies, SpaceX and Slingshot Aerospace. And he's going to share some of the insights and the lessons he learned working for those companies. Steve also talks about engineering processes that tackle difficult problems in deep tech. For example, his team has created an engineering collaboration environment that eases friction when designing, assessing, and managing complex systems. So you're going to enjoy this discussion with Steve and hopefully get some valuable insights that you can implement in your own business. So let's get to my discussion with Steve. Hey, Steve, thanks for joining me on the podcast today.
Hey, Steve, thanks for having me.
So I gave the audience a little intro about you and the call, but everybody wants to know kind of your backstory. What's your journey that got you to the kind of work that you're doing today?
Yeah, it's so we started Prewitt Ridge 4 years ago this month, actually, so just before the pandemic. But prior to that, I guess going all the way back, I went to St. Louis University for undergrad, and there I got really involved in the small satellite program that we were doing out there. This was back 2009, 2010, and this was before CubeSats had really taken off, and we were part of a program called University Nano Satellite, which was the Air Force's way of training young engineers to learn how to build satellites to their standards. And so take a bunch of undergrads, graduate students, give them let them develop a mission that they want to build out, and then send them through their design review process to compete for what was then an incredibly desirable slot on one of their launches for your large scale satellite. Right around that same time, things like the CubeSat launch initiative out of NASA got ramped up. It became a little bit. Access to space started to ramp up pretty significantly, and this was right around the time of the early new space companies, where not only SpaceX but Orbital Aerospace and Massey Space Systems were all in this early part of their new race. And I think SpaceX had launched a few Falcon 1s. I think they've been through the Falcon 1s, and they had done the first Falcon 9. And there was this really interesting confluence in that time period of just going to the conferences, getting exposed to all the space stuff, seeing where the industry could be going, and just wanting to really be involved, and incredibly inspired by everything we were doing at SpaceX, and applied for a job, networked my way into talking to the right folks and making the right friends, and landing an internship there actually right out of college, a place I never thought I'd be, never thought I'd be smart enough to get into early on. But the work we were doing, and just a team of undergrads building a small space system, kind of aligned with the approach they were taking to 2012, 2013, and where they were pulling their talent pool from. So that kind of started my journey going from small satellite undergrad research, going into engineer first in avionics at SpaceX, and then realizing I had an interest in kind of the business side of things, and as well as the customer facing role, and wanting something that touched a lot of different parts of the system. So I took a full-time offer in their mission management department, which was really exciting, right? I mean, this was we worked closely with the customers. We had a department for government, department for commercial, department for Dragon. I was in the commercial side of things, and got to work with people from all over the world who were purchasing launch services on our vehicle, and just work with a bunch of different engineers internally in order to produce all the engineering proof and documentation for all the analyses and results and mission plans to convince the customers that we're going to be good for launch. And especially in that early stage, but those first couple dozen Falcon 9s, that was actually really exciting and fast place to be. I think I actually ended up seeing all of the first Falcon 9s, except for the first two up and through Falcon Heavy, just working there, being involved in some way. And it was really fascinating, the challenges in how to keep everyone on the same page in terms of engineering disciplines. I think it's probably one of the biggest things, right? Because you have folks who are experts in like, loads analysis. You have folks who are an expert in trajectory analysis and planning. And you actually probably don't want those same people to be cross-functionally experts in the other thing as well, because there's already so much knowledge you need to know to be really good at trajectories. You probably don't need to be really, really good at loads analysis and everything that's going on in the vehicle. You don't have time to do that. So that's why we have different disciplines inside of the platform, inside of the company. Mm-hmm. And one of the things that stood out to me is that we would budget like 6 months to do these mission analyses in order for CDR, especially earlier on. And most of that time was just internal scheduling and getting people to like log into the platform and see that I wrote down the right information in our database, or I uploaded the right files and models into the SharePoint directory, and then they would log in and pull it down and run the thing, and we would budget 3 or 4 weeks for each of the disciplines to give them the margin they needed to coordinate with everyone. And if you really like think of the extreme case of how much compute time do you need to just do all that work, it's probably like a day, right? Maybe a little longer, but like most of the time was that human element of like emailing, scheduling, going to people's desks and asking what's up, and like or interpreting the data myself, generating the deliverables, or supporting the analysis any way I could. And that stood out to me as kind of a cost center. So I got involved in some innovation efforts internally to try and tighten that up a little bit. Around the same time, 2017, 2018, I decided to go join another startup called Slingshot Aerospace, where I spent 2 years. It was a really exciting and dynamic place, doing a lot of, a lot harder technical work. My previous role was more program management. This let me get back into actual like software and hardware development. We were doing edge compute on UAVs and spacecraft and working with a lot of the major primes in doing so. And a common thread between all that work was really cool stuff in terms of like computer vision, object detection, and like RF detection, and all these like really exciting like tactical advantage things you would want if you're in an operational environment. You actually saw a common thread where it's a similar problem keeping everyone on the same page. It's just they use different language when you're working with the larger primes at a Northrop or Boeing or a Lockheed, but the underlying concepts are the same. So I started a little more research and realized there's probably an opportunity here. A close friend of mine at the time, my now co-founder, Steve Brechtel, we worked at SpaceX together in mission management, worked on this side project there with Hyperloop that I can talk about later as well. And then stayed climbing buddies while I went to go to Slingshot. Just a lot of time to sit and talk and say, hey, well, why don't we do this thing? And eventually bubbled up to like, well, okay, I guess we'll quit our job and start a company. And so 4 years later, here we are building the software we set out to build with customers on the platform, folks both in commercial and government we're engaging with, and a team of 11 growing it from there.
Okay, great. It's always fun to be working in the industry or in a real role and actually seeing the problem firsthand, because you also see some of the nuances that go with it, and maybe help you're your own potential customer kind of at that point. So what is it, your systems? Are you focused on aerospace now, or do you look at other engineering design issues as well?
Yeah, no, it's a generic problem, whether you're in aerospace, whether you're medical devices, whether you're in energy, whether you're in automotive. it's really, how do you get the software on the chip, on the board, on the box, on the rocket, on the vehicle of some kind.
Okay.
And you need like a dozen different people involved, because each of those different disciplines has a design engineer, build engineer, someone who's responsible, someone doing some testing, and they all have to be off of the same paperwork. And we all hold up these examples of things like the Mars Climate Observer, right, which is a spacecraft that missed its insertion orbit because the ground station had, I think they're using English units instead of imperial, even though all of the interfaces said, hey, we do all of our engineering here in metric. And that itself was just a small miss. And that's really where all of where many of the issues happen, because things that broadly look correct are often enough to, like those errors add up. They'll eat all of your margin. You'll end up losing your vehicle. You'll end up causing a catastrophic failure of some kind. So it's important not only to keep all of the like engineering values, and that's the unit we care about at the finest detail in our company. But you keep all of those engineering values in sync, and we've developed interesting ways in maintaining not only our own authoritative source of truth, but also having to show up correctly in the CAD file, having to show up correctly in the analysis. And that's something that you care about, whether or not you're building, a new wing, a new spacecraft, a new energy source.
Okay. So I've had other guests on, and I know some of the feedback I get from the listeners are, some may work for companies now, but thinking about doing their own startup. How did you, get the momentum to decide to quit, and how do you get through that early phase where maybe you didn't have an immediate customer, maybe you did, but just kind of keeping the momentum going through probably a fair number of obstacles that pop up.
Yeah, and to be honest, I think we broke a lot of the initial rules of like, we had the concept, and we both had a little bit of savings and some, and I actually took a consulting gig as well to pay rent or building it. But like, we just quit our jobs to work on that full time, and that was very stressful. And like, it was very stressful because you have like your own. People talk about runway for the business, which is something you plan for and you build out when you fundraise, and the idea of runways you take off. But the personal runway is incredibly stressful, and so just having enough that set aside that I've been saving up for long enough, because I knew I wanted to quit my job at some point, no matter like across the board, to start something, and then just start to eat into that while we're building out the initial core part of the product. We then built that enough to gain confidence in a business plan to then go fundraise. And then we brought in enough funding to pay ourselves a modest salary, and then bring in some additional support to help implement the thing we proposed to kind of build out with our initial prototype.
Okay. What's one thing that surprised you the most during your kind of startup in the launch? It could be something good, something bad. Maybe something you didn't plan for and it kind of caught you by surprise?
Yeah, that surprised me. It always takes longer than you think to build the thing. It's interesting because I'm technical, right? So I wrote a lot of the initial code of the system, and it is difficult to step away from doing that, even though it's your role as the leadership is to go make connections, go work on marketing, sales engagements, a lot of things that are really fun and exciting on a strategic level. But sometimes you just see something that's a little lagging behind, and you want to be able to jump in and work on it, even though you can't fully communicate why it needs to be the top sprint priority amongst everything else everyone's working on. I compare it to a friend of mine has a restaurant here in LA, and he was talking about how he can like go in and see like, oh no, that's a little off, and that's not something that people would pick up and work on. But like, I'm here, this is my image, my brand, my restaurant, I need to make sure these specific things are correct. And there's this cohesive vision that you have internally, either whether it's just below the surface or not, but there's some amount of like there's something special about the idea that you have, that you quit your job to go work on, that you are starting to see traction and pull in the correct direction for. And the biggest challenge is being able to communicate that, every little piece of the nuance of that to the rest of the team, so they can support building it out and rally around that. So, I guess I was surprised that I was always surprised when I stopped doing development work and then everything really starts to proceed. Then I'm also always surprised that when I jump back in, how exciting it is and how I can support the team on that aspect. And then,
a lot of people that I've talked with, and myself included, they love that development process, that part of your engineering brain. I actually interviewed someone about a year or so ago. He worked at Microsoft at the time, but his morning routine was he got up and wrote code 20 or 30 minutes every single morning because he loved it. That's how he started his day. And his job was, he was an advisor to the CTO at Microsoft, but so it was a little bit different role. But I thought that was interesting. That's just what he loves. That's his passion.
Yeah. And, we're building a technical product. And so what that looks like today is I actually end up using the product to set up the demos. And then that gives us better insight, like where we're going with respect to building it out. And it's you got to jump in and stay fresh with the thing you want to do.
Yep. So if some of the listeners that work with tech companies and maybe they're facing some of the engineering challenges like you did, being sure you're using the right units and all the other things across multiple people or multiple groups, what's the first thing they should be doing to start making sure they don't make a blunder like that, like metric to English or something like that?
Yeah, come to agreement on the unit system is one minimum you should be doing. But it's interesting because the way we start these complex technology programs these days are starting to shift, right? It's less. I guess over the past 20 or 30 years, we've had this focus on, a large top-down organization that then has sub-vendors, and suppliers. And we're seeing a lot more vertical integration, and you end up having a lot more folks in the same room to build out the initial sets of whatever their plan is, whatever they're developing. And I think that's been it's been interesting because it allows you to rapidly iterate on the project really fast and what your concepts are. But on the other side of things, that getting multiple vendors involved, you eventually have to make these rigid definitions of what you're actually building, that you then have effectively a contract of the part needs to plug onto this other piece. I think just the most important thing is to just make sure you're sharing the right information with everyone so that they're able to make the best decision. That goes back to why we founded this company and are building our platform, is that there's the first order information that you want to share. That is, the width of this port that you need to plug into needs to be 0.5 meters. But then there's the downstream information involved with that, what kind of mechanics you need to support everything on either side of that. And there's something, if that port is used for fluid flow, of course, what the flow is through that port. But what if that becomes constricted and you have a sub component 3 layers deep that is then starved of the appropriate fluids that you wouldn't actually find out till a subsequent analysis run of some kind. So trying to just keep everyone connected is the most important thing. And at the earliest stages, that's totally fine if it's a shared Google sheet or a shared Excel sheet, because at least you're writing the data down in a tabular way that folks can then communicate with and know where that central source of truth is.
Okay. As you get these groups with multiple vendors and sub-vendors, do you run into issues with people using different platforms, different software, and trying to get those to talk and understand what units they're using or all the other parameters?
Yeah, absolutely. And it's interesting because it depends on I guess there are interchange formats on the technical side in terms of if you're building CAD, you can go through step, it's an intermediary. But one of the problems trying to solve is you have live data that lives in like a SolidWorks file that lives on a server in the PDM system inside of your company, and you are consuming information that comes from a partner organization or a vendor, and maybe they're all on Team 10 or NX, and you actually the classic way of taking their part and plugging it onto our part and then making sure that integration all works is for them to export to an interchange format, send it over via a secure send site of some kind. You then have a static version of that you can then integrate in your system. And you probably won't lose anything in translation at that aspect. What we are working to get to is, can you have that CAD file as it exists with its multiple revisions inside of your platform, and separately connect to an external platform safely and securely, and then understand when the actual parameters you care about, going back to like that port size, for example, when those actually change, because they don't change because someone just updated the CAD file. Those change because someone updated an upstream unrelated parameter in like a requirements system of some kind. And then they misinterpret the requirements on the other person's end that have been derived from the data they care about. And then you bring the values together for your interface check and it doesn't actually fit. And so what we're trying to solve is not only the process of like, well, how do we make sure these two files fit together, but like, why do they need to fit together? And what's like that core data value that you actually care about, but it's that specific data value you care about that you need to share between the organizations. And that's where you need to capture the BIOS approvals and everything of who's doing what.
Okay. So is that part of your system's called, is it Verve? Is that, am I pronouncing it?
Yes.
Okay. So is that something that your system does, is to help with that coordination and checking and verification and all that?
Correct. Yeah. In fact, two of our customers, one's a spacecraft bus, the other is a payload. And they announced a partnership not too long ago where the bus is going to fly the payload as a hosted payload on their platform. And behind the scenes, they had been doing their initial interface checks and their initial collaboration, their design review on our platform in order to sign in, provide the approvals, share the information. So it's something we're working on today, and it's something we're working on then expanding even deeper so we can have those connections, not only on those numeric values, but then start to dive into where those CAD files and beyond are plugged into.
Okay, all right. So does your system work across a lot of different industries, though? You mentioned that it's a common problem.
Yeah, so our initial go-to-market is in the aerospace sector, because that's just our network. Sure. But we're seeing interest and traction, broader defense, nuclear energy is one, and then medical devices one we're pushing into as well. Like okay. I like to think of it as anything that has a multidisciplinary engineering team with a strong regulatory push as well. Yeah. Because with that regulatory push is some type of like a big push to prove you're building the right thing. Yeah. And being able to build that out and being able to track information and generate that proof is what's incredibly important. Okay.
So what you do is innovative, and I know you're creating new things, inventing new things. What kind of techniques do you have? Don't give away any secrets, but just general techniques do you use for creating innovations, and whether it's brainstorming, or how do you kind of get your team to work together to come up with some of the innovative ideas?
Yeah, and so it's actually been interesting because we raised this funding middle of this year, beginning of the middle of the year, and so we ended up doubling the size of the team. So the way that looks now is very different than what it looked like a year ago. But now today, it's one of the most important things is ownership, and not just ownership of like a single task, like a button on a screen in some way, but it's more ownership around a larger concept or segment of the application we're building out. Okay. And we've always been experimenting with, and being okay to shift between, we'll work on Kanban, and that worked for this stage of the team for 6 months. We'll switch over to like a more formal agile process with 2-week sprints for several months, and then switch to 1-week sprints, depending on what the workload scales to be. One thing we found really, really effective in these past 2 or 3 months in particular is having 3 teams of 3 engineers each. You have the lead engineer is not on any of the other teams. You have a front end developer, a back end developer, and someone who's support. Support's usually someone a little more junior that's shared cross functional between the different teams, so they can be getting that mentorship and then providing that support. But just this really aggressive and radical ownership of larger segments of the platform, and then mapping it to that quarterly sprint cycle. And then separately as a startup, because you have to respond to immediate market needs and your customers, we have this third team, Team X, that is able to perform that without distracting the other team and getting them pulled off of something else. Because that was kind of the earliest, like 2-3 years ago, when we're just 4 people, 5 people. We have to balance the work of going out and doing the sales effort, and then building out what we want to be building, and then building out the things that folks are actively or on the platform actually want, and being able to balance that out. Now we can do them in parallel because of the ownership structure of the teams we've set up.
Okay, interesting. So then do the teams kind of give feedback? If one team's off working on something for a while, a few weeks or a few months, then when they're done, does another team who's kind of coming in with a fresh perspective, can they provide some feedback, or have you thought of this? Does that kind of help with the overall development cycle?
Yeah. I mean, I don't want to say that people are isolated either, and we still have the weekly or biweekly sprint cycle tag up. It's just a little more focused with the team lead, typically presenting a lot of the successes and the wins. People, of course, engaging if there's something specific that they worked on as well. But it's been way more effective in that shared ownership structure in terms of building that out.
Okay.
Separately, three people is about the right group for something that I was honestly wildly opposed to 6 months ago, which is called mob programming. Until we started doing it, because some of the new folks we brought in had a history of doing it at their past jobs, and that's where 3 people work on the same file at the same time, with one person driving. And as a younger developer who grew up, who thought he was a super cool hacker guy who just wanted to work late into the night, that is incredibly offensive to me. Until we sat down and were able to knock out a really obscure token refresh issue that had been plaguing us for a long time, with just 3 of us in a room for 90 minutes, or helping a junior developer get over a hurdle on not fully understanding how to do some internal GraphQL mutation on the back end, on their end, until having them sit down with the person leading the whole GraphQL work, who designed everything, and then one of the other senior developers as well. And just, it's, as far as it really is a net increase in terms of how fast we move. People are really engaged, and it has a bonus effect of working in this post-COVID work structure where we're a hybrid company where half the folks are not based in Los Angeles, half the folks are based in Los Angeles, but we still have pretty expansive work from home. It gives people that targeted and focused interaction that I think a lot of people hold up as that quote unquote water cooler talk, that you would have that ideation process, but it's focused, it's targeted, and actually has a result at the other end. So mob programming, wildly opposed to it a year ago, but it's really cool if done in small bursts.
Well, good that you're open to trying the new things and seeing what works, and like you said, figuring the size, whether it's 3 people or whatever, just testing it to see what works, and especially in your organization, what works for you might not work for somebody else. So good. So as the CEO of Prewitt Ridge, what's the favorite part of your job?
Oh man, I think finding a customer that really agrees with the vision of what you're working on, and then working with them to make improvements and build out the platform. That's really exciting. It's rewarding. In addition to development and sometimes writing code, being able to jump between that and you're building on marketing materials and thinking through how are we presenting the brand and everything to everyone. I think it really is just connecting with folks who are really in alignment with what you're doing, and it's something you can help them out with.
Okay. What are some of the biggest challenges that you, either as a company or kind of your industry, are facing today?
I think the industry, like I guess if I think about the industry we're serving, we better or worse live in an environment with a significantly larger regulatory burden than 40, 50, 60 years ago. I think that's a good thing, and that it's keeping a lot more people safe. But the way we've been responding to that has been labor and time intensive in terms of an aggressive increase in the amount of paperwork you have to produce to prove you're building the right thing, slowing down your development process. I'm not saying we shouldn't have safety engineers. We definitely should, but I think not saying we shouldn't have we shouldn't have these regulations, but we should be able to automate the approval process and the artifact generation process. And I think we're right at the cusp of being able to do that. If I think about our platform, it's set up to provide the data that's been generated in a structured way, and then map it into these artifacts you need to prove that you are building the correct thing and the safe thing. Because you can move really fast at the risk of safety, and I don't agree with throwing safety out the window for that. But I think that there's a lot of really interesting benefits you can have if you can prove that you are compliant to this airworthiness criteria, for example, without having to go and actually write down a bunch of paper or respond to all that. You should be able to automate a lot of that so that everyone is happy and safe, and you proved you built the safest thing. And if you have that part automated, you'll be able to build something even safer, because those aren't separate processes. You're involved with the regulations that we as a society have decided, like, well, it's probably pretty good to not pollute in this direction. You don't have to get all the way to the end to get that stamp of approval. You can then have that type of feedback loop to build something even better.
Okay. All right. Interesting. So what's ahead as we record this now? We're rolling up on the end of 2023, and as people are listening, it'll be early 24. But what's ahead for you and your team for the next 12 or 18 months?
Yeah, so we're really excited about building out more integrations into other engineering tools, really accelerate folks in their development. I think there's, I think just getting plugged into more and more of the places where engineers are doing real work is really exciting. And I also, we're looking at really novel and interesting ways of what's the step beyond that. I mean, how do you start to fill in the blanks between not only generating the document artifacts you need to engage with external parties? How can you plug into these engineering tools and start to support generation of new parts at the other end? I think we're a ways off from that, but I think a core part of that is having structured engineering data under the hood in the database, which we're already providing, hooks into the engineering tools people are doing that individually generative work in, which we're already providing. Then how do you start to bridge the gap of like, well, now you're going a layer up in terms of your part definition or your system definition, and then you're starting to start to even generate some of the parts, whether mechanical, electrical, or even code at some point in the future. I think that'll be really interesting. I think we're set up to support that. But I think we're really at the cusp of like taking a lot of these wild AI developments we've been watching over the past not only year, but like that's been a big buildup past decade at that point, getting better. It's really good at making silly images or making things that are like convincingly something that is maybe where am I going with this? There's an extra level of reality when you're dealing with physical properties, and you still need some level of framework there to test again. If you're going to be using some sort of generative design process to build against. And so our system is set up to support that, and now it's all about, well, how can we start to pull that into the platform and show how we can really support that?
Okay. Well, it sounds like that should keep you busy for you and the team for the next year or two at least, and well beyond. I do a lot of reading, and I always love to have recommendations for books. So, what's a favorite book that you've read or listened to recently, fiction or nonfiction? What's a favorite?
Obviously for science fiction, anything by Alistair Reynolds is really exciting. He's a former European Space Agency physicist who switched to science fiction writing probably about 20 years ago. Read one of his actually older books outside of his main series a couple of months ago that really stuck with me. I'm blanking on the name. It's not Pushing Ice. That's his main one. It's Terminal World. It's called Terminal World. And the way it starts out is almost more feels more like fantasy. And I don't really want to explain more and give away more of the book, but if you've read any of Alistair Reynolds' larger scale science fiction, like space opera style books, he does a really good job of knowing the underlying physics of how the world should work, and as well builds out these really rich characters that traverse around the known universe according to that.
Okay.
It's probably one of my favorite ones. There's another nonfiction book that I really like called, it's got a silly title. It's called The Dawn of Everything. It is not an anthropological look at human society and the history of society, but an archaeological look. So it tries to take cues from what have we found in societies that have since died out and that have gone through, for whatever reason, and trying to determine, well, how are these societies structured, and starts to challenge that narrative of, well, there's just this natural progression from hunter-gatherer to agriculture to just living in these violent little cities, or these cities with like violence on the outside. And actually, like there's you need to look at the history of society throughout. Well, people voluntarily banded together. They would establish leadership in some natural way. And it was just over time where, we got to the process that has both the certain hierarchies in our society, as well as agriculture, as well as things like money. And you should take a step back to really understand where we came from. You don't want to ask the question, where did inequality come from? But you want to start by asking the question, when did we start to ask the question, where did inequality come from? Because then that starts to peel back the layers. The author is David Graeber. He's written a few other books, one about the history of debt as well, which is pretty interesting. So this isn't his first attempt at something super ambitious.
Okay. Well, great. I will put those titles and authors in the show notes and a link to find the books for any of the listeners. And I'm certainly going to add them to my list. I haven't read either one yet, but I love the sci-fi, so I will definitely, that one will probably be a little higher on the list for me. But thank you for sharing that. Appreciate that. I always get recommendations of things that I'm not aware of, so it's always nice to.
What are you reading right now or recently?
I'm not reading anything, although I may go back and actually read the book series. I watched The Expanse, that series, and just loved it. But I realized the books can have a different approach or more in them, and I know the books go beyond what the TV series did. So that's my excitement.
Yeah, they start to deviate actually pretty substantially, like the second or third book. It's pretty interesting. So it's good. Which is nice. It's not just rehashing what they're showing. It's a good different adventure, and you start to see where they like picked different like character traits from different parts and like to make the TV show series. So it's a good read.
Yeah, so I'll get those on my list. But so I want to thank you for your time, Steve, and sharing all your knowledge and thoughts. Valuable. I know the audience gets a lot out of this. If any of the listeners have questions or they want to learn more about you or more about Prewitt Ridge, what's the best way to reach out?
Yeah, you can reach out to my email, just steve@prewittridge.com. can also reach out to me on LinkedIn as well. Not really on the other social platforms. So I think either of those are pretty good. We'd love to talk with anyone who's super passionate in this space. I know it's pretty opinionated field. It's been pretty fun to work in this. So
Okay. And I'll put links to your LinkedIn profile as well as your email in the show notes as well. So anyone who's listening. I just want to say thanks. I love the conversation. I got a lot out of it. I knew I would, because we had talked previously, and I know the audience is going to get some good insights out of this as well. So thanks for taking time out of your busy schedule to talk with us today. And I'll let you get back to your projects.
yeah, likewise. Thanks so much, Steve. Really appreciated the conversation. Thanks for your time as well.
Yep.